Hello, welcome to this walking talking mock. We're looking today at calculate questions. So we've looked at compare, we've looked at describe, we've looked at using graphs. So this is the fourth walking talking mock. We're going to look at, as I say, calculate questions, which are slightly different, and we're going to use a slightly different mnemonic to help us to make sure we get all the marks for these calculate questions. Specifically here we're looking for calculate questions that have more than one mark available, where there are little sneaky things that the examiner might have put in to try and trick you, to catch you out. So for this session you're going to need a pen, a pencil, a ruler and a calculator. Okay, you're going to need all four of those things. Can you make sure you've got those ready right now, please? And let's start by looking through this new mnemonic we're going to use. So we've already used, remember we've already used cub, okay, and that's the one we generally use for all questions. But for calculate questions we also add this additional one here, cercar. Now cercar is apparently Spanish for to plough through, so we're going to plough through these calculations using cercar. And with cercar what we're going to do is we're going to star the thing we're trying to find. So we're going to put a little star next to it. We're going to underline key points in the same way that we do with cub. We're going to rewrite values. So whenever we see a value in a question, we're going to rewrite it on our answer sheet. Okay, now that will make sense why we're doing that in a little while. We're going to convert units. So what we're talking about there is if I've got something in millimeters, I'm going to convert that into meters. I'm going to add values into the equation, so I'm going to use the equation that I'm going to need, and I'm going to write the values into that equation, and then the last thing we're going to do is we're going to rearrange that equation if we need to. Okay, if you are very happy with maths, you're good at maths, and algebra is your thing, then quite often what you might try and do is you might try and rearrange the equation before you add the values in. The danger of doing that is if you make a mistake, you lose the marks for adding values into the equation. Okay, so you lose 2 marks if you were to make a mistake doing that. Whereas if you add the values first, you'll get the mark for that. And then if you rearrange incorrectly, you lose 1 mark. Okay, so we're always going to try and add the values into the equation and then rearrange right at the very end and find the answer. Okay, so let's look at question 1 first of all, and this is a bit of a recap on some of the skills we've already looked at. So, a student is investigating speeds of 2 different cars. Their results are shown in the graph below. Okay, so we've got 2 cars. We've got car 1 and the X's here, and car 2 are these diamond shapes here. And it's time against speed, centimetres per second. So what does the question ask us to do? Draw a line of best fit for car 1. So this is a draw question. We have to draw a line of best fit. The data for car 1. So I'm cubbing the question. It's worth 1 mark. I don't need to do any bullet points for this. I've got to just draw the line of best fit. So remember how we're going to do this? We're drawing a line of best fit for these X's here. Okay, we imagine where would the next X go? I'm going to do this in red pen here. Where would the next X go? Well, looking at this pattern, I'm expecting the next ones to be kind of out here somewhere. Maybe look in between some points. Where would you expect there to be an X there? Look, where would you expect the cross to be over here? Where would you expect them to be? Well, it's probably going to be somewhere around here. Probably expecting something around here. Okay, and if you're doing that, if you can correctly identify that you imagine they're going to be in that kind of place there, then the chances are you've already seen that pattern, and the pattern is definitely here. It's definitely a curved pattern. This is not a straight line. Okay, so we shouldn't be using our ruler. So to get that curved pattern, we're going to rely on muscle memory. I might need to turn my page around a little bit just to help. And we're not going to sketch like this. As soon as I do that, I've lost a mark. I'm definitely not going to do dot to dot. Okay, we don't do that in science either. This is a line of best fit, so it's going to be sort of try as much as I can to follow the pattern that I can imagine in my head where these x's should go. Okay, so you have a go at that now. Let's see how I get on. Okay, so I'm happy with that. One smooth movement. Okay, I've got, doesn't matter, I don't have to go through any points at all, but I've got roughly the same number of crosses above, or I've got some crosses above the line and some crosses below the line. That's okay. Okay, that's quite a hard one to draw that. And I'm happy with that, so I'm going to move on to the next question. Circle any anomalous data points for car 1. It's worth 1 mark. Anomalous. Okay, so anomalous results don't fit the pattern. They stand out. Okay, they stand out as not fitting the pattern. So do any of these points look like they don't fit the pattern? Well, actually, that one's not bad. It's not far away from the line. That one's not far away from the line. The only one possibly I might say is this one here, because it looks like actually this levels off constantly up here, doesn't it? It looks like it stays about the same. Possibly. So I'm going to circle that one. But I'm going to write in it maybe because it seems as if the graph levels out. Now if you decided that there were no anomalous results in that, I think that would be fair as well. Okay, next question. Okay, cover the question first, remember. Use the graph. Okay, so use the graph to predict the speed of car 1 after 80 seconds. It's worth 2 marks. Okay, so 2 marks again. We're not going to cub this one, but I've got to use the graph. So that's my two marks here. One mark for using the graph. And how do I show that I'm using the graph? Well, what I'm going to do is I have to draw on that graph. And 80 seconds, which is here. So I'm going to draw a line straight up there. And a line straight across. There. And it looks like that's very, very close to 60. So I would imagine for that. So use graph to predict the speed of car after 80 seconds. That's going to be 60, and the units centimeters per second. Describe the trend shown by the data for car 1. Okay, so this is a describe question, so say what I see. The trend is just another word for pattern, shown by the data for car 1. So there's no point, and it's worth 2 marks. So there's no point at all me talking about car 2 here. Okay, car 1. And this actually is the perfect opportunity for me to use the perfect conclusion statement that we spoke about in the last walking talking mock. So it's worth 2 marks, so 2 bullet points. 1, 2. So first of all, what is it? Is it a hill or a valley? Am I going uphill or downhill? Well, if I start there, I start at the origin always, I'm going that way, and I end up over here, going that way. Well, I've gone uphill, so as time increases, speed increases. Okay, so as time increases, speed increases. What's happening to the steepness? Okay, what's happening to the steepness? It starts very steep, and if you can imagine walking up this hill, it's getting less and less steep. I'm still going uphill, but it's getting less steep until eventually it flattens off entirely. It's not steep at all. Okay, so as time increases, speed increases, with a decreasing steepness or rate. Okay, remember steepness and rate are the same thing. Okay, so that's a perfect conclusion. both marks for that question, no problem at all. Question E. Cub this question, please. Compare the patterns, speeds of car 1 and car 2. 3 marks. So 3 bullet points for this one. Right, let's just push that away. So 3 bullet points. So 1, 2, 3. If I look here, I'm looking for things to talk about these two shapes. So I've got this line here, black line, and this line here, curved line. I need 3 comparisons. It's about spotting 3 things that are different between them both. Well, where should we start? Let's start at the fastest they go. So car 1 reaches a speed of about 72 centimeters a second, whereas car 1 is slower. So car 2. So car 2 reaches, it doesn't say to use the graph, so I don't need to put any data in if I don't want to. Car 2 reaches a higher top speed. Just check, is that a comparative sentence or not? And yes, it is, because I've used higher, so that tells me it must be faster than car 1. Okay, what else is going on? Well, both cars start at 0 centimeters per second and get faster. Okay, so I've talked about the end point. This one ends much higher. Let's talk about the start point. This one starts much. They both start at the same points, 0 centimeters per second. So they're both not moving, and they both get faster. And I need another comparison as well. So, well, now I'm talking about the shape. So I've already talked about the start, I've talked about the end, and it's the way they get there. So car 2, look, it's got a constant rate of change, constant steepness or rate of change. Okay, so it gets faster at a constant rate, whereas car 2 gets faster at a constant rate, whereas car 1 does not. So car 1 gets faster at constant rate or steepness. Okay, I'm talking about steepness there, but the word, I have to use the word rate to get a mark. Car 1 gets faster at a constant rate. Now that's not enough, because that doesn't give me any information about car 2, so I need to make sure I say about car 2 as well. Car 2 does not. Okay, and that would be fine, because I've already said that car 2, in my previous answer, car 2 increases at a decreasing rate. Okay, right, let's look at the next question. Could you cub question 2, please, and use circar?